Okay, this is section 11.4. We're going to talk about percent yield. And the objectives in this video are to talk about how to calculate the theoretical yield of reaction from some data we're given and determine the percent yield for a chemical reaction. Okay, so we already know how to do the theoretical yield. That's what we've been doing on these stoichiometry equations, is figuring out, yeah, so many grams of a product. You want to figure out how many grams of a product were produced from so many grams of a reactant. That's the theoretical yield. That's what we've been calculating. And the percent yield is really pretty simple after we figure out what the theoretical yield is. The hard part in these, the percent yield is the easy part. Okay, so how much product do we get from a reaction? Okay, in theory, this first part up here, the theoretical yield, sets the maximum amount of product we should get in a reaction. Okay, so, but that's not what always happens, right? The actual yield, if you do an experiment, the actual yield that you get from doing an experiment with so many grams of a product and getting so many grams of a reactant is going to be less than that theoretical yield. And the percent yield is the is the is just the actual yield divided by the theoretical yield, what we get from our calculations here in the theoretical versus what we actually get doing an experiment in the lab. So the actual we get from the lab, the theoretical we get from calculations, divide the actual divided by the theoretical, multiply it by 100 to change it in percents, and that's what gives us our percent yield. Okay, so there's different reasons why that happens. Mostly it's because the reactants don't always mix well with each other. They stick to the sides of the containers. There's competing reactions to form other products that may or may not be the minor products from the reactions might happen that we don't usually take into effect. And the reason this is important is because the percent yield stuff is important in a manufacturing process, is if they can, they need to figure out how much of a product they can get in a certain reaction, and they can figure out the percent yield. To do that is important. Okay, so how do you calculate the theoretical yield of a chemical reaction? Okay, so this is pretty easy when they give us everything like this. They said calculate the theoretical yield of a chemical reaction starting with 50 grams of reactant is 25 grams of product. So that's our theoretical. We should get 25 grams if everything reacted with everything. And what is the percent yield if the actual was only 22%? 22 grams, sorry. So the percent yield is just the actual divided by the theoretical. So in this case, we're going to do, let me get the right thing here. Why can't I do my pen like I want to? Okay, sorry about that little glitch. Okay, so what we want to do here is figure out the percent yield. It's pretty easy when they give us this kind of problem. We don't even need the chemical reaction or anything. We just know that the actual yield is 22.0 grams over the theoretical yield, which is 25.0 grams, equals 0.88. And then we multiply that times 100, gives us 88% as our percent yield for this problem here. So that's the basics of percent yield. The problem is going to be they almost always give us this, they almost always give us this 22%. But really the hard part is figuring out, they don't always give us how many things like that. They give us what we have to start with here with the 50 grams, and then you have to figure out, that the theoretical would have been 25. And then after that, figuring out the percent yield is easy. So this is just kind of more practice on the stoichiometry equations, figuring out the percent yield. Okay, so here's a problem that, yeah, okay, here's a problem we have with, it has this up here is benzene. Okay, so benzene reacts with chlorine to form benzochlorine and HCl, hydrochloric acid, but it's just HCl in a gas form. And the typical thing is if you have 36.8 grams of this benzene reacts with an excess of chlorine. So we have plenty of chlorine. We don't even know how much. But we have enough to plenty to react with that. So it's the limiting reactant is the benzene. And they gave us the actual yield was 38.8. So we got a little more than we started with this, with the chlorine atom. And this equation is balanced. So you can check it. It's all 1, 1, 1, 1. So it's all balanced. So what's the percent yield of that? So we have to figure out our theoretical yield, right? So to do that, we have to set up our ratios, okay? We have to set up over here, we've got our grams of, well, we start with the grams of benzene. We have to change those grams to the moles. This is our grams of moles given. So we have to figure out the atomic mass of C6H6, put that here on the bottom, 1 mole on the top, and our molar ratio. In this equation, though, the molar ratio is just going to be 1 to 1 because oops, all the subscripts are, all the subscripts are 1, okay? But and then so we'll figure out how many moles of whatever we started with. We'll have the same number of moles of whatever we end up with. Then we have to change those grams, those moles, I mean, back to grams of this new molar mass over here. Okay, so it looks like this. When we do the theoretical yield, you do the 36.8 grams of benzene divided by the 78.12. We get that from just adding up the molar masses of C6H6. So that's how many moles of benzene we start with, and it's just 1 to 1. So we have the same number over here, and each mole of the product here of this C6H5Cl is going to weigh 112.56. So whatever moles we get, we're going to get multiply 36 times 8 divided by 78 and multiplied by 112, and you come up with this 53.0. So what's the percent yield? The percent yield is just what we were given, the 38.8. That's what we got from the experiment divided by the 53. So we're going to get 73.2%. Okay, so that's a quick look at how to do percent yield. It's actually more problems of the same we've been doing with the theoretical yield. This part of the problem is the figuring out the theoretical yield is the hard part. Figuring out the percent yield is easy because they almost always give you the what came from the lab, and you have to figure out what the theoretical yield is the only tough part. Okay, so watch the fill out the form below, and I'll see you guys in class tomorrow.